I'd like to go down the list of numbers, that types of numbers that hopefully you have now learned about. And the first numbers anybody dealt with were the natural numbers, the counting numbers. So the natural numbers, and this is represented by capital N, written this way. It's written kind of funny in mathematics. We write the N with two vertical lines on the left. The natural numbers are the ones we count with, beginning with 1. Now when you tack on 0, and believe me, the number 0 was an incredible innovation. The Romans never used a number 0, neither, I don't believe the Greeks did either. Off the top of my head, I forgot who came up with 0, but it may have been the Persian and Hindu world. The Hindu-Arabic system had a 0. And so when we tack on 0 to the natural numbers, we get the whole numbers. So it's really the same as the natural numbers with 0 added onto it. Those are called whole numbers. The integers really came along with the advent of algebra. People resisted actually the negative numbers for quite some time. The mathematicians and philosophers were pretty much the same at one point in history. And at any rate, the philosophers said, look, show me a negative quantity of something. And we can't do that. I can't hold up a negative number of marking pens, for example. We can't see negatives, negative quantities. And so the philosophers reasonably said, well, okay, if you can't demonstrate the physical reality of a negative number, then it must not exist. And then why are you messing with these? So there was a lot of resistance to negative numbers until probably, I think they came into general acceptance around the 1500s and 1600s, that finally we found some good uses for negative numbers. There are really two reasons for negative numbers. If you have a scale that is open-ended, if it extends in both directions, then wherever you put 0, there's a right side and a left side. So the left side is negative, the right side is positive. The other reason for negatives is anytime you're modeling motion that goes in one direction, the opposite direction has to be negative. And so negative gives you a sense of direction when you combine it with positive. All right, so this gives us the integers. And the integers, the symbol for that is z, and the z is written with two little slash marks there. The z, if you're wondering, that comes from the German word zählen. Zählen means to count. And so that's where the integers come from. But integers, of course, are whole numbers that can be negative or positive. So they are unlimited, but they're still whole numbers with a proviso that they can also be negative or positive or 0. All right, well, early on, people realized that we wanted to divide things up into parts. And so when you divide natural numbers into parts, you create fractions. Well, if you extend this down to the integers, all fractions, which can be negative or positive or 0, are called rational numbers. So the rational numbers are fractions. They're the fractions. And their symbol is Q, capital Q with a little double mark there. And then when we fill in the gaps of the rational numbers, we also include the irrational numbers. And I spoke about this earlier, that actually most numbers are irrational. They're in decimal form. They have no clear pattern to them. There's no pattern that repeats itself. They don't end. For example, the square root of 2 proved that was irrational. So when we combine the irrational numbers, and I don't know a symbol for those, with the rational numbers, we get the real numbers. The real numbers. So the real numbers are represented by a fancy R. Kind of looks like one of the R's on the Rolls-Royce symbol. Real numbers, you think of, this is the full continuum of all the numbers on a number line. And it's any number that can be written in a decimal form is a real number. So you might think, well, gosh, that's all of them, isn't it? Are there any other numbers? Well, that's the end of the one-dimensional numbers. When we introduce the imaginary unit and combine it with real numbers, then we get a two-dimensional number, which I'm going to illustrate with drawings. And these two-dimensional numbers are called the complex numbers. So that's going to be the main topic here for this section. The complex numbers are represented by a C, and it really is a combination of two sets. It's the real numbers, and it's the real numbers times I, the imaginary unit I. So anyway, I've laid out a bunch of different number systems that we refer to in mathematics, and just to make a point that mathematicians like to classify things into various categories, and each of these has its own algebra to it. So if you studied algebra at a more abstract level, which I have, and most people in my position have studied algebra at a somewhat more abstract level, then you learn about fields and groups and rings and things like this. And you learn how to classify different kinds of algebraic systems of numbers. Okay, well, let's get on with it, and I'm going to erase the board and let's talk about complex numbers. Okay, I don't know if you can hear this through the camera, but it's raining pretty hard outside, so you might hear that through the camera. It's coming down very heavy right now. Anyway, let's talk about complex numbers. And the definition of a complex number is a number which has this form: a plus bi, where a and b are real numbers. All right, so this is a fancy way of saying that both letters A and B represent real numbers, element of the real number system. And recall, real numbers are just all the ordinary numbers you can write in some kind of decimal or fraction form. Regular numbers. But when we add on the imaginary unit I, the square root of -1, and combine it here, then we get a different type of number known as a complex number. And complex numbers are two-dimensional in character. So I don't know if you ever thought about numbers in terms of dimensions, but it's true. Because it requires two pieces to describe it. In order to picture it, you've got to represent it on a two-dimensional plane. It truly is two-dimensional. Now this portion of it is called the real part. And this portion, the b times I, is called the imaginary part. So there are names to these, and parts of the complex numbers. All right, so let me give you an example of this.